50 matched pairs of magnitude and depth measurements are randomly selected from 10,594 earthquakes recorded in 1 year from a location in Southern California. So that's what we have here in column A and column B. So each row is an earthquake. So if you look at row 2, the magnitude of the earthquake was 2.12 and the depth was 3.5 meters. So we want to look at, is there a relationship between magnitude of the earthquake and the depth of the earthquake? And we want to find the best predicted depth of an earthquake if the magnitude is 0.9. And we're going to use a significance level of 0.05. And what that means is the significance level of 0.05. All that means is we're going to use this column for our critical values, the column for 0.05. So we're going to ignore this one for alpha equals 0.01. Okay, so before we get started, if we want to predict a y value based on an x value, well, there's one of two things could happen. The correlation coefficient is large enough to say, yes, there is a relationship between these two variables, in which case we'll use the regression equation to predict the y value. Or the answer is no. The correlation coefficient is too small to say there is a relationship between these two values, but in this case between the magnitude and the depth. So let's start off, and I have a cell over here set aside for the correlation coefficient. So let's look at the correlation coefficient for this data. So we have column A as magnitude and column B as depth. So the correlation coefficient equals CORREL. That's the Excel function for correlation coefficient, and our x values are column A, and our y values are column B. So our correlation coefficient is negative 0.2203 something. All right, so that's a very weak correlation. So now what we have to do is compare that to the critical value. And the critical value is based on two things. The fact that we have 50 pairs of data and the significance level is 0.05. So we'll come over here on the right to the critical values. We'll go down to n equals 50, and our critical values, plural, are plus or minus 0.279. All right, so what that means is, so basically, we could say the correlation coefficient is going to be between -1 and 1, and the critical values, so let's say 0 is right here in the middle. The critical values are 0.279 and negative 0.279. And if the correlation coefficient is in this range or in this range, the answer is yes. There is a relationship between these two data values. In this case, between magnitude of the earthquake and depth of the earthquake. And if it's in the middle, the answer is no. So over here, there's a yes and a no. So in this case, the correlation coefficient, negative 0.22, puts us, let's see, in here, in the no range. So it's less than or sorry, it's actually it's greater than negative 0.279. Just make that a little bit more noticeable. So since the correlation coefficient is between the critical values, the answer is no. No, there is not a statistical correlation between these two variables. And in that case, we can't use the regression equation. The only time the regression equation is a good model is if the correlation coefficient is large enough. But in this case, it's not. So, since the answer is no, we're going to go over here. And the best predicted y value, regardless of the value of x. So in this case, regardless of this, regardless of the fact that x is 0.9, the best predicted y value is y bar, the mean of the y values. So, since our correlation coefficient, since this is very small, and actually the absolute value of this is smaller than the absolute value of the critical value, our best predicted y value is the average of the y values. Okay, so let's put that maybe in this cell right here. Let's highlight this. We can make this blue. So the best predicted y value is equal to the average of column B, the average of the y values, which in this case is about 11 point, well, let's round this to 1 decimal place, is about 11.5. So that is our best predicted y value. And the only reason we're using the average of the y's is because, let's switch this up, let's make this blue. The only reason we're using the average of the y values is because the correlation coefficient is too small. The absolute value of the correlation coefficient is smaller than the absolute value of the critical value, or it's between plus and minus 0.279. All right, so that does it for this problem. So just keep in mind, if you're predicting a y value, the only time you could use the regression equation is if you first answer yes to the question, is there a statistical correlation or is there a relationship? So if there is a relationship between these two sets, then we could use the regression equation, that y equals mx plus b, or in the context of statistics, that y equals b0 plus b1x. The only time we could use that is if the correlation coefficient is large enough. Okay, I hope this was helpful.